Hello and welcome to a video. Today we're going to see if we can't build a glitch camera using one of these cheapo kids toy cameras, as well as a little circuit board that I designed. First off, I'd like to thank PCB. Like the first video I did in this series, they let me prototype these flexible boards and provided them for this project. So big shout out to them, and I appreciate them sponsoring this video. The idea behind this board is that we can solder it in place inside the camera that makes it easier to access all the pins that come out of the camera's little sensor module. The idea there being it makes it way easier to access those teeny tiny little pins so that we can play around and try to circuit bend. Now the reason I wanted to go this route is because bending cameras is super difficult. A, and I wanted to make it much easier. But B, I also wanted to make it much easier to experiment. So I think this board is a step in the right direction because it will hopefully make it much easier to play around and experiment with these cameras. And that way you don't have to mess around with tiny micro soldering every time you want to try something new and something different. Hopefully having these through-hole connection points will make that a lot easier. And one of the things that I wanted to talk about is how circuit bending is an inherently experimental thing. And whenever I make a tool like this, the idea is not necessarily that you just do exactly what I do and build your own version of exactly what I do. If you're just getting started, there's nothing wrong with following someone else's project and figuring out how it works. But the ultimate goal of circuit bending is to experiment and to make something of your own. So whenever I develop little tools like this, my hope is that you will be able to use them for your own projects and not just to recreate something that I've built. As Reed Ghazala himself put it, circuit bending is not a, attach this wire here to this wire here. I think I'm butchering the quote, but something along the lines of, it's not a this wire goes here type of art. Instead, it's all about you experimenting. And I'm hoping that once this project is complete, it will enable you all to not just recreate what I'm going to do today, but also experiment with your own designs. Now, if you saw the first video, this is my second version of this board. You don't have to have seen the first video to, follow along with this one. But in case you did, the other version of this board, I had selfishly kind of pre-built out dedicated connections for the way that I like to circuit bend these. I've gotten rid of those to A, make it small enough to fit in the camera better, and B, to encourage that experimentation. I don't want it to come across like, oh, you're supposed to use it this one specific way. The other thing I've changed is I've tried to make it much easier to attach. Now, instead of just having one little connector on the side, it's actually got a double-sided connector right at the edge that we should be able to basically place and solder much easier. You can see this board is itty-bitty, but you can see I've marked pin 1 here, and then we've got our tiny connector all the way across. And when I flip it over, you see I can solder it from either side, and I've got my pin 1 is marked over here. So no matter what orientation your connector is in, you can flip this either way and connect to it. Also, because it's double-sided, we should be able to bump this up against the camera's connector and just flow solder so that it connects from these pins over onto the original PCB connector. I'm hoping that will make this much easier to solder in place than my first version was. With all that said, let's get started. This one I'm going to be showing a lot more of the process of actually bending the camera. First thing we're going to do is basically just open it up. And these are super simple. They've just got 4 itty-bitty little Phillips head screws. And for those of you who might be new and may not already know, I have like a goofy left hand. So if you see it wobbling around a little bit or wondering what's up with the funky glove, that's what it is. I basically had a stroke a couple of years ago, and now my left side's a little bit goofy. Once that's off, it just opens right up. And you'll want to be careful because the camera sensor is attached to the front piece of the shell. The rest of the guts are in the back. And this, it'll either be held in with 1 or 2 screws. A lot of times it's got a place for 2 screws, but a lot of times they cheap out and just put 1 in there. It is wild to think about manufacturing at that scale where having 1 less screw makes a difference. Next, we've got the camera board. I'm just going to remove this from its case entirely. It's just once again held down with a few screws, and I almost always forget this, but we want to remove the SD card before we try to take this board out. Next up, you can see the screen is kind of just clipped into place in a few different locations. And we really just want to pop that out with a spudger. And just be gentle, use something plastic, and go slow. So now we are left with our little camera module. And this is how I prefer to work on these. Just because with this very specific model, you can see, here's the connector where we've got our camera sensor coming out. And then on the back, we have this empty mirrored connector. And those are actually the same thing. They actually connect with all the same points all the way through. It is really nice. This just gives you a lot more real estate to solder to. First thing I'm gonna do is just try to get this positioned. I'm trying to make use of this sticky stuff here to hold it in place for me. If your camera doesn't have that, that's totally fine. You could use a piece of masking tape. And what I'm going to do for my first attempt here, I'm just going to use a regular old soldering iron and see if I can flow the solder across these connectors and get a good connection that way. For those of you who may not be familiar with my videos, I mentioned my goofy hand earlier. Because of that goofy hand, I solder one-handed, and basically I solder wrong. So I'm not the person to go to if you are looking to learn how to solder and you can use both of your hands. I do not recommend doing it the way I do. And the first thing that I'm going to do is just flood this thing with a ton of flux. Now I'm going to clean off all this nasty flux, and then we'll take a look at it under the microscope and see how we did. I wanted to give it that first try without a microscope, because ideally, I would love for folks who don't have microscopes to be able to do this. Since I have one, we may as well use it to see how we did. Here we can see our nice shiny connection. There we go. So at an angle you can see where the solder is flown over the edge of the board and then down onto the contacts. So even though they're on, a different plane like that, the solder has flown over to make a connection there. Now, the last thing I want to do is just test our connectivity and make sure before I move on that we really got it. What I'm going to do now, I've got my meter and I'm going to connect this probe to some of the different through-hole points. And then I'll check up here to make sure we have continuity. All right, sounds like we've got continuity. There we go, and I'm just raking the pins to make sure I don't have any sort of across. Just a quick spot check there, but that is looking good. I've got my glue gun heating up. I'm just going to put a layer of hot glue across those connections, down over onto the edges of the PCB here a little bit. That way, as we're bending and messing around with all these little contacts down here, we don't have to worry about accidentally ripping up our connections that we've made. For those of you who have seen my videos before, you may notice it says Get Circuit Bent instead of Peter Cat Productions. I'm actually changing over the name of everything, including this YouTube channel, to be Get Circuit Bent. It's still just me, it's still the same stuff, but the reason I'm changing is because having the channel and the work I do under the name Poetaster, which no one knew how to pronounce, and then Peter Cat Productions, which didn't sound in any way related to Poetaster. I'm just kind of putting everything all under one roof so it makes a little more sense. But yeah, if you see Get Circuit Bent, that is now going to be me. All right, let's put some hot glue down. When we're messing around with connections, being able to see how it affects different colors and different lighting situations is really helpful. Now, the first thing I'm going to do, at least one of these connection points is carrying power to power on this camera module. And I do not want to use that one. First thing I'm going to do, I'm going to try to find my ground pins.
A little longer than a few minutes later.
I am back. I had a minor distraction there where I kept showing a bunch of pins as ground, and I was really confused as to why. And then I realized that I had the camera on. So when the camera is on, different pins on the camera module are going to be pulled high or pulled low, meaning grounded in the case of pulled low. Okay. As far as actual grounds go, pins 3 and 15 are both checking out as ground. '21 and 22 are also ground. Next up, we are going to look for our voltage. This one I will want it turned on. Now what I'm doing, I've switched my meter over into voltage mode. Checking pin 1. Oh, I've got a little tiny voltage. And because I've got my positive on the ground, it is going to read as a negative voltage. And as I mentioned earlier, some pins will be high, some pins will be low during the normal operation. These super low voltages that are showing up in millivolts, I'm not really worried about. What I'm trying to find, there should be at least one pin that reads, probably around 5 volts if I had to guess. Okay, so 16. I'm reading at 2.7 volts. So far, that is our kind of winner as far as the highest voltage. And 17. But yeah, I show you my horrible handwriting, but I've just made a quick cheat sheet. The pins 13 and 19, I read 1.5 volts. Pins 16, 17, and 24, read at 2.7 volts. I'm guessing these are our power supply, and we just want to stay away from any of these when we're playing around. The reason I mapped that out first is if we took this, you saw how low the voltages were on some of those other points. If we took this power supply voltage and crossed it with one of those data lines that just had a few millivolts running through it, we could burn up the sensor or the CPU that kind of reads the sensor and makes an image out of it. super easily. That's kind of the quickest way to end your glitch camera project, is if you accidentally put one of those power lines to something else. So it's always good to do with anything, but especially if you are messing with a camera module. Let's go ahead and map out what your grounds are and what your high voltages are. So now that we can see what we're doing and we know our stay away pins, let's start experimenting. We know that pin 3 is a ground, and we know pins 1 and 2 are both safe. So let's see what happens if I ground out pin 1. And the answer is nothing. Same for pin 2. And I'm just using my tweezers here to short the pins. Ooh, 3 and 6. There we go. See, we get that wonderful green sparkly effect.
Two hours later.
And basically, this is kind of how you would go around experimenting. We would just remember we're not going to screw around with pins 16, 17, or 24. Probably also not messing with 13 or 19.
Eventually.
What I'm going to do here is just kind of map out a quick idea of what we want to do. So how I like to design these in general is with 2 switches and with 2 pots. So that means basically we can have 2 different pins coming into a switch, and we can swap which one comes out of it. And then we can have a pot. Then the same thing over here. Oh yeah, I should talk about how this works. So when the potentiometer is kind of in the middle, there's a lot of resistance between the center pin, which we're going to connect to our switch output. So basically whatever's coming out of the switch is in the middle. And when the potentiometer is in the center, there's enough resistance that no glitches are really happening. But as we adjust the potentiometer between either of these, it will start to create one of those glitches we saw. But it'll be adjustable because we can change the resistance with the potentiometer. So because 7 and 9 do pretty similar stuff, having 7 and 9 on both sides of one potentiometer isn't actually ideal. That's the old design that I used to use, is the reason why I'm talking about that one specifically. But I'm going to change it up because since those 2 are so similar, we can get more bang for our buck if we use different ones. So for instance, if we put 6 and 7 here, 6 looks good with 9 or ground. Basically, if we swap between these 2, we can either put ground or 9 here, and then glitch it with 6 or 7. Just checking, 7 also looks good with 9 or ground. So all combinations of these glitches will look good. I have a confession to make. I got carried away, and off camera I did a little more poking around. It's totally against the rules of how I normally approach videos. I try to show the whole thing. But since this is a one-off, and I think you've gotten the gist of what I mean by experimenting with different points, I think it should be fine to skip that. Hopefully y'all agree. What I discovered poking around is that pin 20 also works well with a number of our other points. So I've come up with this potential diagram, and what we're going to do now is I'm just going to go through and test each one of these glitch combinations and just make sure that nothing is too similar to each other. Make sure we've got a nice mix of glitches before we wire anything up. I am happy with that. So I think this is the design we're going to go with. I will put together a proper schematic so you don't have to try to read my horrible handwriting. And I'll display it here. So next up, we just need to install the controls in our camera shell. I think all of these parts I typically source off of Amazon. They're not too hard to find. You can see inside the shell, I try to mount all these controls in this little bulge out area, just because it gives us more clearance. When you look at the sides here, you can see these little ridges, and these kind of handily mark out where we're going to put everything. So in this large gap here, that's where our first potentiometer is going to go. You can see this package lines up beautifully. And closer to the bottom, we've got a second one of these. And you can see this other one has an extra little ridge in here. We're going to trim that out later. Now for the switches, we have the smaller kind of gaps here. So there's one here up towards the top. You can see this switch fits in there nicely. On the lower end, try to get my hand out of the way so you can see. But you can see that switch also fits in there nicely. So the switches are going to come through the back, out the front, and the pots are going to come through the side. The right way to do this is probably to like measure it out and be all fancy. But honestly, I just usually kind of hold things in place and eyeball it. What I'm going to do first, I've got a small pilot hole bit in here. I'm going to use that to drill the holes. Alright, next up I've just swapped in a stepper bit. And these are great because you kind of just go until you have the right size you need. Next, I'm just going to do a test fit, and you can see from the front, this is where those switches will be. Before I clean up, I'm going to go ahead and drill the holes for our potentiometers as well. And just like before, I'm going to drill little pilot holes. Next up, I'm basically just going to test fit all the hardware and make sure it all fits in at the same time. So you can see how all that hardware fits in there now. It's a snug fit, but there is room for all of these controls to fit in there. I've gotten the controls installed here. See how it looks after everything's tightened up. This is something to be aware of when you're constructing these. You want to make sure you don't accidentally short out any of your controls on the SD card holder, because this is just a big grounded metal shell right here. If any of your controls touch this, it'll glitch out the camera when you don't want it to. And this is the hard reset button, and you definitely don't want to accidentally be triggering hard resets. But now we are ready to go ahead and get this wired up. I won't make you, in the final video, watch me cutting wire. But just to recap, the color code I came up with, pin number 20 will be the blue wire. Pin number 3, which is our ground, we're gonna stick with the standard black wire. For pin 7, I'll be using red. Pin 11 will be yellow. Pin 6 will be green. And pin 9 will be white.
3 hours later.
Can you move it along? I'm all out of time cards.
Okay, I got them all. And the solders actually look pretty darn clean from underneath. And while I've got this flipped up, what I'm going to do is I'm going to sneak a bit of electrical tape right here. Just to make sure I don't accidentally get anything interfering with this chip right here. Sorting these wires out. Now for the next part, we are going to wire these connections up to our controls here. And that's all of our controls soldered up. So we are just about done. We are just about ready to close this up and wrap up the video. I think I'm going to end with a montage of photos and videos that I take using our finished glitch camera here, just to give you an idea of what it can do. So before we move too far along into that, I did just want to take a moment to say thank you to PCBWay for sponsoring this video and for providing the prototype boards, both for this video and the last one. They've been a tremendous help through this whole project, so a big shout out to them. And I also want to thank everyone who subscribes to the channel, likes the videos, comments, all that good stuff. It's a free way to support the channel and what I'm trying to do here. So if you haven't done that yet, it would be a huge help if you do. I appreciate it. And yeah, I think that's all the plugs I need to do and whatnot. Before I go too much further, I'm going to just do a quick test fit here. Okay, that looks good. And I think I mentioned this before, but I'm also going to put some electrical tape here just to prevent any of our controls from accidentally making contact with this board. All right, so we're all closed up. Let me give it one final check. 1, 2, 3, 4, 5, 6, 7, 8. All right, all 8 glitches are working after we've successfully closed it up, so I think this one is done. So thanks so much for watching, and again, thanks so much for liking, subscribing, all that nonsense. And to close it out, we'll just run through some photos and videos that I took with this guy.
When you feel comfortable, try to hold it.